January 1st, 1888, Saint Rémi, Quebec. A child entered the world in a small farming community where French was the only language spoken and prospects for advancement seemed limited. Jean Cantius Garand was born into a family that would eventually include 12 children, 6 boys and 6 girls, all sharing the same first name, Jean le Baptiste. Only this boy would go by the English version of that name. Only this boy would leave an indelible mark on military history. 11 years later, tragedy struck. The children's mother died, leaving their father to raise 12 children alone on a Quebec farm. The decision was made quickly. The family would move south to Connecticut, to a place where work could be found in the textile mills that powered New England's industrial economy. The boy who spoke only French would learn English while sweeping floors. The boy who had never held a rifle would discover a fascination with firearms that bordered on obsession. What happened next would prove that formal education was not required for revolutionary thinking. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. That an immigrant child with no engineering degree could design a weapon that military experts insisted was impossible, and that 40 aimed shots per minute, a rate of fire that seemed fantastical to every army in the world, would become the standard that changed infantry warfare forever. The textile mill in Jewett City, Connecticut, was not where most people would expect a military revolution to begin. Young Jean Garand swept floors and gradually learned the machinist's trade. The precision required to maintain the looms and spinning machines taught him to think about mechanical systems in ways that formal engineering schools never could. Every gear, every cam, every linkage had to work perfectly or production stopped. This was education through necessity, through the unforgiving reality of industrial machinery that either functioned or failed. Near the mill, a gun club maintained a target, range. Shooters left their rifles at the Garand home between matches. John and his brothers learned to shoot. They studied the mechanisms. They understood intuitively what many trained engineers never grasped, that a rifle was simply a machine that needed to perform one task reliably, repeatedly, under the worst possible conditions. By 1909, the 21-year-old had developed sufficient skill to be hired by Brown and Sharp, a precision toolmaking company in Providence, Rhode Island. The work demanded tolerances measured in thousandths of an inch. It required understanding how materials behaved under stress, how friction could be managed, how complex mechanical systems could be simplified without sacrificing function. For 7 years, Garand refined his understanding of manufacturing. Then came 1917. The United States entered the Great War in April 1917. The War Department issued a call for designs for a new light machine gun. Garand, working with another designer named John Kewish, developed a prototype. Their design used a primer-actuated mechanism, a novel approach that attracted attention from the National Bureau of Standards. In June 1918, they demonstrated their weapon. It showed promise. The war ended before production could begin, but the demonstration had accomplished something more valuable than a military contract. The United States government had noticed that a self-taught machinist from Connecticut understood firearms design at a level that rivaled trained military engineers. On November 4, 1919, John Garand was offered a position as a consulting engineer at Springfield Armory in Massachusetts. He accepted immediately. He became a United States citizen in 1920, and he began work on a challenge that had frustrated every major arms manufacturer in the world for 3 decades. The challenge was simple to state and apparently impossible to solve. Semi-automatic rifle that could fire as rapidly as a soldier could pull the trigger. Make it reliable enough to function in mud, sand, snow, and tropical humidity. Make it accurate enough for a soldier to hit targets at 500 yards. Make it simple enough that conscripts with minimal training could maintain it. And make it manufacturable in quantities of millions. According to every firearms expert in America and Europe, this combination of requirements was unachievable. Semi-automatic actions were complex and prone to malfunction. Gas-operated systems fouled quickly. Magazines were fragile and easily lost. The forces involved in automatic operation disrupted accuracy. The Springfield Model 1903 bolt-action rifle worked perfectly well, they argued. Why pursue an impossible goal when a proven weapon already existed? Jean Garand disagreed. Not because he was arrogant or dismissive of established knowledge, but because he understood something that the experts had forgotten. Every supposedly impossible mechanical problem had a solution. The solution simply required questioning every assumption that everyone else accepted as unchangeable. The Springfield Armory's experimental shop in the early 1920s was a space filled with overhead belt-driven machinery, precision lathes, and the constant sound of metal being shaped to exacting specifications. Garand worked at a bench in the corner, surrounded by drawings, prototypes, and rejected designs. His initial approach used a primer-actuated blowback system. When a cartridge fired, the pressure from the primer would drive a piston that cycled the action. It was elegant, it was novel, it did not work reliably. Testing at Fort Benning in 1925 compared Garand's Model 1922 against designs by Berthier, Hatcher-Bang, Thompson, and Pedersen. None proved conclusively superior. The Ordnance Board requested modifications. Garand returned to his drawings. He had learned a crucial lesson. Novelty was not the goal. Reliability was the goal. By 1927, Garand had switched to a gas-operated system. When a cartridge fired, propellant gases would be diverted through a port in the barrel into a cylinder containing a piston. The piston would drive an operating rod backward, cycling the action. This was not a new concept, but Garand's implementation was different. His design routed the gas cylinder below the barrel. This kept the rifle's profile low. It maintained the sight line. It simplified maintenance. The Army Ordnance Committee complicated matters by demanding the rifle use a new 276 caliber cartridge that was being developed simultaneously. This smaller, lighter round was supposed to be the future of military ammunition. Garand redesigned his rifle for the 276 cartridge. Testing in 1928 and 1929 showed promise. The rifle functioned reliably. Accuracy was excellent. The Ordnance Board was ready to proceed with adoption. Then, General Douglas MacArthur intervened. On February 25, 1932, the Adjutant General, speaking for the Secretary of War, ordered all work on rifles and ammunition in 276 caliber to cease immediately and completely. The reason was practical but frustrating. The military had enormous stocks of 30-06 Springfield ammunition left over from the Great War. Changing calibers would require scrapping millions of rounds. During the Great Depression, with military budgets slashed to minimum levels, this was economically impossible. Garand had to start over. His 276 rifle had to be completely redesigned for the much more powerful 30-06 cartridge. The increased chamber pressure required stronger materials. The heavier recoil demanded modifications to the gas system. The larger cartridge changed the magazine capacity from 10 rounds to 8. Years of work seemed wasted. This is where Garand proved his exceptional ability. Rather than simply scaling up the 276 design, he fundamentally reconsidered every component. The operating rod was redesigned to handle greater forces. The bolt was strengthened. The gas cylinder was repositioned. The stock was shaped to channel recoil forces straight back into the shooter's shoulder rather than allowing the muzzle to climb. Each change was tested exhaustively. Each modification was refined through countless iterations. On August 3, 1933, the T1E2 prototype became the United States rifle, caliber 30 M1. It was not officially adopted yet. That would require field trials, but the designation indicated the Army believed Garand's design might finally work. In May 1934, 75 M1 rifles went to field trials. 50 went to infantry units, 25 to cavalry. The reports came back filled with problems. The rifle jammed in dusty conditions. The gas system fouled after extended firing. The trigger mechanism was unreliable. Lesser designers would have given up. Garand returned to his bench. He modified the gas system. He redesigned the trigger. he improved the ejection mechanism. He developed specialized tools and gauges to ensure each component met precise tolerances. On November 7, 1935, the rifle was cleared for procurement. On January 9, 1936, it was standardized as the official service rifle of the United States Army. On July 21, 1937, the first production model was successfully proof-fired, function-fired, and fired for accuracy. 17 years had passed since Garand began work at Springfield Armory. 17 years of rejected prototypes, demanding requirements, budget constraints, and technical obstacles. But now production could begin. The United States military would be equipped with the world's first standard-issue semi-automatic rifle, and the mathematics of infantry combat were about to change fundamentally. The M1 Garand, as it came to be universally known, was 43.6 inches long and weighed 9.5 pounds. It fired the 30-06 Springfield cartridge, the same powerful round that had served American forces since 1906. The cartridge propelled a 150-grain bullet at approximately 2,800 feet per second, delivering substantial energy at extended ranges. Effective range was 500 yards. Maximum range exceeded 3,000 yards. The rifle fed from an 8-round en-bloc clip. Unlike a detachable magazine, this clip was inserted directly into the rifle's action. When the last round fired, the clip automatically ejected with a distinctive metallic ping. Some worried this sound would alert enemies that the shooter was reloading. Combat veterans universally reported that battlefield noise made the ping inaudible beyond a few yards. The concern proved groundless. The gas-operated action worked with mechanical precision. When a round fired, propellant gases were diverted through a port drilled in the barrel approximately 6 inches from the muzzle. These gases entered a cylinder containing a long-stroke piston. The gas pressure drove the piston rearward. The piston was connected to an operating rod that extended back along the right side of the barrel. The operating rod engaged a rotating bolt inside the receiver. As the operating rod moved backward, it rotated the bolt to unlock 2 locking lugs from recesses in the receiver. The bolt continued rearward, extracting and ejecting the spent cartridge case. A spring-loaded magazine follower pushed the next cartridge upward. As the operating rod returned forward under spring pressure, it stripped the new cartridge from the clip, chambered it, rotated the bolt to lock, and cocked the hammer. The entire cycle took a fraction of a second. The action remained closed between shots. The barrel did not move. The sight picture was minimally disturbed. This was the critical advantage. A soldier armed with a bolt-action rifle had to break his aim after every shot, work the bolt to eject and reload, reacquire his target, and fire. The process took roughly 4 seconds for a trained soldier. During those 4 seconds, the enemy could move, take cover, or return fire. A soldier with an M1 Garand simply pulled the trigger 8 times in rapid succession. His aim barely changed. His target remained in his sights. He could fire all 8 rounds in 15 to 20 seconds while maintaining effective accuracy. The rate of fire numbers told the story. A German soldier with a Carabiner 98K bolt-action rifle could fire approximately 15 aimed rounds per minute. A British soldier with a Lee Enfield could manage perhaps 18 rounds per minute with its 10-round magazine and smooth bolt action. An American soldier with an M1 Garand could fire 40 to 50 aimed rounds per minute. Not wild, unaimed bursts, aimed fire, shots that hit their targets. This represented a fundamental shift in infantry firepower. In a 2-minute engagement, a German rifleman might fire 30 rounds. An American rifleman could fire 80 to 100 rounds. More critically, those 100 rounds would be delivered in sustained strings of rapid fire rather than in the pause-fire-pause rhythm of bolt-action operation. The psychological impact on enemies facing this volume of accurate fire cannot be overstated. But in 1937, when production began, none of this was proven. The rifle existed only in small numbers. Springfield Armory's production rate was 10 rifles per day. At that pace, equipping the entire United States Army would take decades. The rifle's theoretical advantages needed to be validated in actual combat, and the industrial capacity to manufacture millions of rifles needed to be created from nothing. Springfield Armory in 1937 was not prepared for mass production of a modern firearm. The facility had not tooled up to produce a new rifle since 1903. Much of the production equipment was obsolete. Severe budget cuts during the Great Depression had resulted in the termination or retirement of experienced workmen. Some within the armory doubted whether efficient mass production of the M1 was even possible. The rifle's breech mechanism was considerably more complex than a bolt-action rifle. Components required tighter tolerances. The gas system needed precise alignment between barrel and operating rod. Any variation in dimensions could cause malfunctions. Critics argued the rifle could not be manufactured in quantity to the required specifications. Jean Garand proved them wrong by designing the manufacturing process as methodically as he had designed the rifle. He created specialized tools, jigs, and gauges specifically for M1 production. He designed fixtures that ensured consistent alignment. He developed inspection procedures that caught defects before assembly. He personally supervised the installation of new machinery. The receiver, the heart of the rifle, was forged from heat-treated steel. Garand designed the forging dies. The dies had to be milled from hardened tool steel to precise dimensions. They wore out quickly and needed constant replacement, so Garand designed multi-head mills that could produce 3 dies simultaneously. Once forged, each receiver was machined to final dimensions on specialized lathes and milling machines. The barrel required extraordinary precision. Rifling had to be cut in a consistent spiral along the entire length. The gas port had to be drilled at exactly the right location and angle. The chamber had to be reamed to precise dimensions. Garand specified the machinery, trained the operators, and inspected the results. The wooden stock presented its own challenges. Traditional gun stock manufacturing was labor-intensive, requiring skilled craftsmen to hand-shape each piece. Garand revolutionized the process by adapting Blanchard lathes, machines that could carve complex shapes by following a pattern. A single Blanchard lathe operator could produce as many stocks in a day as 3 skilled stockmakers. By the end of World War II, advanced Blanchard lathes were cutting and sanding 3 stocks simultaneously. But even these automated tools could only shape the exterior. The interior required precise milling to create voids for the barrel and action. Garand designed automated inletting machines that carried multiple stocks through a sequence of cutting operations, vacuuming the wood chips as they worked. What had once been skilled handwork became mechanized production. By January 1941, production had reached 600 rifles per day. By January 1942, production exceeded 1,000 rifles per day. Springfield Armory produced 4,188,669 M1 rifles between 1937 and 1945. Winchester Repeating Arms produced an additional 513,880 rifles between December 1940 and June 1945. The industrial achievement was staggering, but the rifle still needed to prove itself in combat. That proof came sooner than anyone expected, in a place few Americans had heard of before December 7, 1941. The Philippine Division of the United States Army had been equipped with M1 Garand rifles, beginning in August 1941. Elite Philippine scouts received the new rifles. These were experienced soldiers, many with years of service. They trained extensively with the M1, learning to take advantage of its rapid-fire capability. They had no idea how soon that training would be tested. On December 8, 1941, the morning after Pearl Harbor, Japanese forces invaded the Philippines. The campaign would ultimately end in American defeat, surrender, the Bataan Death March, and years of brutal occupation. But in the initial fighting, something remarkable happened. Japanese commanders reported that American and Philippine scout units were engaging them with what appeared to be machine gun fire from individual riflemen. The reports were accurate. A soldier firing an M1 Garand as rapidly as he could pull the trigger produced a sustained volume of fire that sounded like automatic weapons. 20 to 30 aimed shots per minute was the conservative estimate during those first engagements. Some soldiers, in the chaos of combat, fired all 8 rounds in seconds, reloaded, and continued firing. The distinctive crack 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 of M1 fire, without the pauses required by bolt-action rifles, created an acoustic signature that Japanese troops learned to recognize and fear. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. General Douglas MacArthur cabled Washington in February 1942, praising the rifle's performance. He specifically noted its effectiveness in the dust and dirt of foxhole fighting, conditions that would have disabled less robust weapons. The M1 Garand's first battle was a defeat for American forces, but it was a vindication of Jean Garand's design. By November 1942, American forces were engaging German and Italian troops in North Africa during Operation Torch. German intelligence assessments of American equipment painted a picture of industrial abundance but military inexperience. The M1 Garand appeared in these reports as a semi-automatic rifle of interest but not particular concern. German analysts noted its 8-round capacity and self-loading mechanism, but concluded that it sacrificed the accuracy and reliability inherent in simpler bolt-action mechanisms. German soldiers carrying Karabiner 98K rifles expected to dominate firefights through superior training and tactical skill. The Kar-98K was an excellent weapon, accurate to 550 yards with iron sights, reliable in extreme conditions, simple enough for conscripts to maintain. German infantry doctrine emphasized aimed fire from prepared positions. A skilled German soldier could fire 15 aimed rounds per minute from his Kar-98K. When German and American infantry first engaged in North Africa, the volume of American rifle fire was shocking. Not machine gun fire, which Germans expected and knew how to handle, but rifle fire, continuous, sustained rifle fire. German soldiers would fire, work the bolt, reacquire the target, fire again. Perhaps 15 rounds per minute from trained soldiers, but each American opposing them was firing 30 to 40 rounds per minute, multiple aimed shots without pausing to cycle a bolt. The mathematics were undeniable. In a 2-minute engagement, a German soldier with a Kar-98K might fire 30 rounds. An American with an M1 Garand could fire 80 rounds. The German soldier had to break his sight picture with every shot. The American simply kept his target in his sights and pulled the trigger. When both soldiers were equally trained and skilled, the American would hit 2 to 3 times as many targets. In squad-level engagements, this difference became overwhelming. The M1 Garand gave American infantry numerical superiority in firepower, even when German forces outnumbered them in actual soldiers. German commanders adjusted tactics. They increased emphasis on superior positioning, better use of cover, coordination with machine guns and mortars. These measures helped, but eventually, the sheer volume of aimed fire from American infantry would find targets, suppress defensive positions, and enable American maneuver elements to advance. The psychological impact on German soldiers manifested in profound ways. They had been conditioned by propaganda to believe in Germanic technological and tactical superiority. When individual German infantrymen, properly equipped and well-trained, found themselves unable to win firefights against individual American infantrymen, the myth of superiority collapsed. German after-action reports began referring to American Bispoled rifle fire as if it were automatic weapons. Some reports claimed Americans were equipped with semi-automatic rifles in much greater numbers than intelligence had indicated. Both assessments were attempts to explain an uncomfortable reality. American soldiers armed with M1 Garands possessed a fundamental advantage that training and tactics could not overcome. The weapon each soldier carried made a measurable difference in combat effectiveness. Studies of small unit actions after the war consistently showed American infantry inflicting disproportionate casualties in firefights. The rifle made the difference. General George S. Patton wrote to the Chief of Ordnance on January 26, 1945. His assessment was unambiguous. In my opinion, the M1 rifle is the greatest battle implement ever devised. This was not hyperbole from a general known for colourful language. Patton understood infantry combat at a level few officers achieved. He recognized that the M1 Garand had fundamentally changed how infantry fought. A soldier armed with an M1 possessed firepower equivalent to multiple riflemen with bolt-action weapons without sacrificing accuracy, reliability, or effective range. By June 6, 1944, D-Day, virtually every American rifleman landing on the beaches of Normandy carried an M1 Garand. This represented an unprecedented achievement. An entire military force numbering in the millions was armed with semi-automatic rifles, while opponents still carried bolt-action weapons. The advantage was not subtle. It was overwhelming, and it was proven in thousands of engagements across France, Belgium, and Germany. The M1 Garand served through the invasion of Sicily in July 1943, through the hedgerow fighting in Normandy, through the liberation of Paris, through the Battle of the Bulge beginning December 16, 1944, through the crossing of the Rhine and the final drive into Germany. In every engagement, the rifle performed reliably. Soldiers learned to trust it. When mud clogged the action, they field-stripped and cleaned it. When parts wore out, they replaced them. The rifle kept working. In the Pacific theater, the M1 proved equally effective. Island fighting from Guadalcanal to Okinawa subjected the rifle to conditions worse than European combat. Salt water, coral dust, tropical humidity, sand. The M1 functioned. Japanese soldiers, armed with Type 38 or Type 99 Arisaka bolt-action rifles, faced the same overwhelming firepower disadvantage that German soldiers experienced. Japanese banzai charges that had succeeded against Chinese troops armed with bolt-action rifles consistently failed against American forces armed with M1 Garands. The sustained volume of accurate fire broke attacks that traditional infantry weapons could not stop. By the time production stopped in 1957, more than 5,400,000 M1 Garand rifles had been manufactured. Springfield Armory produced the majority. Winchester, International Harvester, and Harrington and Richardson produced hundreds of thousands more. The rifle served as America's standard infantry weapon through World War II, through the Korean War beginning June 25, 1950, and into the early years of Vietnam. It was not officially replaced until the M14 was adopted on March 26, 1958, with full transition taking until 1961. Even then, M1 Garands remained in service with Army Reserve and National Guard units into the 1970s. The rifle was provided as military aid to American allies worldwide. South Korea, West Germany, Italy, Japan, Denmark, Greece, Turkey, Iran, and dozens of other nations received surplus M1 rifles. Due to their durability and reliability, M1 Garands have appeared in conflicts as recently as Iraq and Afghanistan. The rifle that entered service in 1937 remained relevant 80 years later. Jean Garand never received royalties for his design. On January 20, 1936, he transferred all rights regarding his inventions to the United States government. He felt his salary as an engineer was sufficient compensation. A bill was introduced in Congress to award him $100,000 in appreciation. The bill did not pass. Garand remained in his consulting position at Springfield Armory until his retirement in 1953 at age 65. He received the Meritorious Civilian Service Award in 1941. He received the First Medal for Merit, together with Albert Hoyt Taylor, on March 28, 1944. He was awarded the Alexander L. Holly Medal from the American Society of Mechanical Engineers. In 1973, 1 year before his death, he was inducted into the United States Army Ordnance Corps Hall of Fame. The citation acknowledged both his inventive genius and his engineering skills, noting that his contributions served an important role in the history of World War II. The man himself remained modest throughout his life. He avoided publicity. He rarely gave interviews. He was more comfortable in machine shops than in corporate offices. When reporters did manage to speak with him, they found a soft-spoken man more interested in discussing technical details than receiving credit for his achievements. He let his work speak for itself. Jean Garand died in Springfield, Massachusetts, on February 16, 1974. He was 86 years old. He is buried at Hillcrest Park Cemetery in Springfield. His legacy extends far beyond the millions of rifles that bear his name. He proved that formal education is not required for revolutionary innovation. He proved that questioning accepted wisdom can lead to breakthroughs that experts miss. He proved that an immigrant child sweeping floors in a textile mill could rise to change military history. The M1 Garand's impact on warfare extends and beyond World War II and Korea. The rifle demonstrated conclusively that infantry benefit from self-loading rifles that increase their rate of fire without sacrificing accuracy. This principle became foundational to all subsequent military rifle development. Every modern infantry rifle, from the AK-47 to the M16 to current assault rifles, owes conceptual debt to the M1 Garand. It established the baseline against which all other infantry rifles are measured. The 40 aimed shots per minute that seemed impossible in 1920 became standard by 1940. The gas-operated action that military experts dismissed as too complex to manufacture became the mechanism used in most modern rifles. The en-bloc clip system, controversial during development, proved so efficient that production rates reached levels previously considered unattainable. The straight-line stock design that channeled recoil backward instead of upward influenced every subsequent rifle design. The story of the M1 Garand is fundamentally a story about challenging assumptions. Every expert in the firearms industry believed semi-automatic rifles were too complex for general issue. Jean Garand proved them wrong. Military procurement officials believed manufacturing to required tolerances was impossible at scale. Garand designed the tools and processes that proved them wrong. Combat commanders initially doubted whether soldiers could maintain the rifle in field conditions. 17 years of combat across every environment on Earth proved them wrong. The immigrant who spoke no English when he arrived in Connecticut at age 11 became the designer of the weapon that armed the most powerful military force in history. The boy who swept floors learned precision manufacturing that surpassed university-trained engineers. The self-taught machinist solved problems that had frustrated firearms designers for decades. The quiet engineer who transferred all his patent rights to the government for no compensation created a legacy that continues 87 years after the first production rifle was built. When German infantry encountered American forces armed with M1 Garands in Tunisia in November 1942, they faced a technological reality that contradicted everything their training had taught them. The sustained crack, 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 crack of American rifle fire, without the pauses required for bolt operation, announced a new era in infantry combat, the era when one skilled soldier with a superior weapon could dominate multiple opponents with inferior arms, the era when rate of fire mattered as much as accuracy, the era that Jean Garand, working methodically in a Springfield Armory experimental shop, had made inevitable. The 40 aimed shots per minute that gave this video its title were not hyperbole. They were documented, measured, and proven in combat across 2 theaters of war and 3 major conflicts. They represented a tripling of effective infantry firepower compared to bolt-action rifles. They transformed infantry tactics from careful aimed fire, from static positions to fire and maneuver, suppressive fire and rapid assault. They enabled the modern infantry combat doctrine that assumes soldiers carry weapons capable of sustained rapid fire. The rifle they said could not be made was made. The rate of fire they said was impossible became standard. The immigrant they might have dismissed as unqualified designed the weapon that defined American infantry power for 3 decades. And the mathematics of infantry combat, unchanged since the invention of the bolt-action rifle, were rewritten by a man who understood that every impossible problem simply required questioning every assumption everyone else accepted as unchangeable. The most remarkable aspect of the M1 Garand story is not the rifle itself, but what it revealed about the nature of innovation and institutional resistance. When Jean Garand first proposed a gas-operated semi-automatic rifle in the early 1920s, the response from military procurement officials was not merely skepticism. It was certainty that the concept was fundamentally flawed. These were not ignorant men, they were experienced officers with engineering degrees from prestigious institutions. They had overseen weapons procurement through the Great War. They understood firearms design according to every principle that had been validated over decades of development. And they were wrong. Catastrophically, expensively, dangerously wrong. Their certainty was based on assumptions that had never been properly questioned. Semi-automatic actions were complex, therefore unreliable. Gas systems fouled quickly, therefore unsuitable for military service. Soldiers would lose detachable magazines, therefore internal magazines were required. High rates of fire encouraged waste of ammunition, therefore aimed fire from bolt-action rifles was superior. Each assumption seemed reasonable. Each was repeated so often it became accepted as truth, and each was proven false by a self-taught machinist who refused to accept them. The institutional cost of this resistance cannot be calculated precisely, but the outlines are clear. If the M1 Garand had been adopted in 1928, when early prototypes showed promise, American forces entering World War II would have had 13 additional years of training and tactical development with semi-automatic rifles. The Philippines in December 1941 might have been defended more effectively. North Africa in November 1942 would have seen even more one-sided engagements. The cumulative advantage across millions of infantry encounters would have been substantial, but institutions resist change. They resist most strongly when change comes from unexpected sources. Jean Garand was not part of the military establishment. He had not attended West Point. He had not studied at prestigious engineering schools. He was an immigrant who learned English while sweeping floors. The fact that his design was superior to alternatives proposed by established manufacturers was almost irrelevant to those who controlled procurement decisions. What mattered was institutional prestige, established relationships, and the comfortable assumption that expertise resided in traditional places. This pattern repeats throughout military history. The British Army resisted machine guns because cavalry officers believed the bayonet charge remained the decisive factor in warfare. The French Army built the Maginot Line because defensive fortifications had proven successful in the previous war. The German Navy built battleships when naval aviation had already made them obsolete. In each case, established institutions with access to the best information and most experienced personnel made decisions that subsequent events proved disastrously wrong. The M1 Garand succeeded despite institutional resistance, not because institutions embraced innovation. Production began only after years of field trials that repeatedly demonstrated the rifle's superiority. Even then, some Springfield Armory personnel insisted mass production was impossible. Even after the rifle entered service, some officers continued to advocate for bolt-action rifles on the grounds that semi-automatic operation encouraged ammunition waste. The rifle had to prove itself in combat before skepticism finally subsided. What saved American soldiers was not military foresight but Jean Garand's determination. He continued refining his design through 17 years of testing, modification, and institutional obstruction. He personally designed the manufacturing tools and processes that made mass production possible. He trained the workers who built the rifles. He created the quality control procedures that ensured reliability. He did not wait for permission or approval. He simply built what he knew was right and let results speak for themselves. This is the lesson that institutions find most difficult to accept. Innovation often comes from unexpected places. Expertise is not always correlated with credentials. The person who solves an impossible problem may be someone who does not realize the problem is impossible. Organizations that dismiss ideas based on the source rather than the merit of the idea pay catastrophic costs in efficiency, capability, and lives. The M1 Garand armed American forces through the most consequential conflicts of the 20th century. It provided soldiers facing determined enemies with a technological advantage that translated directly into survival. Every soldier who fired 40 aimed shots per minute while his opponent struggled to fire 15 owed his advantage to an immigrant machinist who refused to accept that the goal was impossible. Every tactical innovation enabled by sustained rifle fire traced back to a self-taught engineer who questioned assumptions that everyone else accepted without examination. The story of how one immigrant's impossible design gave American soldiers the ability to fire 40 aimed shots per minute is ultimately a story about the cost of institutional arrogance and the value of persistent innovation. It is a reminder that the next revolutionary breakthrough may come from someone who lacks traditional qualifications but possesses something more valuable: the willingness to question what everyone else knows to be true, and it stands as testament to what one determined individual, armed with intelligence and unwillingness to accept conventional wisdom, can achieve against all odds and all expectations. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.